Alright, this video is going to be on how the unit circle is constructed, which is important to know later if you need the unit circle, and I'm going to have you memorize it, of course. And let's say you brain fart on a test or something and all of a sudden you forgot part of the unit circle, then at least if you know where it comes from, you might be able to think through what value it is you're struggling to find. So we're going to go ahead and flip this over on the back and construct it real quick and see where all the numbers come from. So first, we have some special right triangles, and this is known as the 45-45-90 triangle. So these two angles would be congruent here. And so the two sides that correspond with those angles would be the same measurement, A and A. And if we did the Pythagorean theorem, we would find that the third side is the square root of 2 multiplied by A. Another special right triangle is a 30-60-90 triangle. So that would look more like this. And here's your 30-degree angle right there and your 60-degree angle right there. And on this one, the little side is a measurement of A, the long side is a measurement of 2A, and then the third side, if we were to use the Pythagorean theorem, is the square root of 3 multiplied by A. And I'm not sure if you guys learned about this. It used to be that in middle school, often learning about triangles, you'd study this, maybe in geometry in high school a little bit, but in some curriculum they've taken it out. Okay, so the next thing we're going to draw is we're going to do just like the first quadrant of the unit circle. So if we copy this down, oh, it's kind of circular. Alright, and if we go ahead and measure, let's say right hereabouts, that's where the 30-degree angle would be. And I'm going to go ahead and make a triangle right there. So on the edge of the circle, this is going to be some coordinate where we have an x and a y value, right? And this down here is a 30-degree angle, and I dropped this line straight down, so that's a 90-degree angle. And then right here would be our 60-degree angle for that 30-60-90 triangle that we have going on right there. Alright, now in a unit circle, we always consider the hypotenuse of the triangle to be a length of 1. So that's the radius of the circle. A unit circle would have a radius of 1. So at this point, now what we're trying to do is we're trying to solve for this length right here, which actually corresponds to the x-coordinate, because it's how far you went to the right to get to that point. And then we need to know how far you go up to get to that point, so this would be the y-coordinate right there. So now if we use this information and we compare it to what we have with our 30-60-90 triangle, if we look here, the long side is a length of 2A. So in our triangle, our length of 1 is the same as the 2A side. So I'm going to go ahead and solve for A, because then I can plug it in for A to find the length of my other sides. So I'm going to say A equals 1/2. So then over here for y, the length of A is 1/2, and so that means that the y-coordinate is 1/2. And over here, the length for x is root 3 multiplied by A, so that's root 3 multiplied by 1/2. And we'd put that over 1 so we could multiply those things together. So now I've got root 3 over 2. So x equals root 3 over 2. So for my 30-degree angle, I have an x-coordinate of root 3 over 2 and a y-coordinate of 1/2. So I'm going to go ahead and flip my unit circle over. On this, for 30 degrees, my x value was root 3 over 2. My y value was 1 over 2. Alright. Next, we're going to go ahead and we'll do the 60-degree angle next, because I think that will be easiest. So 60 degrees would be about right there. So here's our 60-degree angle, here's our 30-degree angle. We still have a radius of 1. And if you notice, this is the exact same triangle we just dealt with. It's just oriented differently. So that means that the side across from the 30-degree angle is still going to be 1/2, just like it was before. And the side across from the 60-degree angle is still going to be root 3 over 2. And so that means that the x and y coordinate that correspond right here would be 1/2 root 3 over 2. And that was for the 60-degree angle. So for 60 degrees, I've got 1/2 and root 3 over 2. Okay, and then we're going to go ahead and do the 45-degree angle. So this one would be directly in the middle. So here's our 90, and then we've got 45, 45. Again, the hypotenuse is a length of 1. And now if I go back up and I compare the hypotenuse with the hypotenuse of the 45, 45, 90 triangle, then the 1 in the triangle I just drew corresponds with root 2 times a. So I'm going to say the 1 equals the root 2 times a side. The other sides were written as a, so once I solve for a here, then I know what the length of the other sides are. So I'm going to divide by root 2. So a is the same as 1 over root 2, and that's not proper. We're not supposed to leave radicals on the bottom of a fraction. So I'm going to multiply it by 1. So root 2 over root 2 is 1. It means I'm changing the form of my fraction, but I'm not changing the decimal that it equals. I'm just changing what it looks like. So 1 times root 2 is just root 2. Root 2 times root 2 is the square root of 4, which is just 2. So these other sides are root 2 over 2, root 2 over 2. All right, so let's go back and we'll go ahead and write this in here. 45, we've got root 2 over 2, root 2 over 2. Okay. And then for this one right here, this is 0 degrees. And if I think about this as the unit circle has a radius of 1 again, so my x value here would be 1 and my y value would be 0 because I haven't gone up at all. And then here we've got 90 degrees. Here the x value would be 0, but the y value would be 1. Over here we have 180 degrees, so I went left 1, but not up or down at all. And down here I've got 270 degrees, and I didn't go left or right, but I did go down. Alright, now at this point I'll go ahead and fill in the rest of these degrees. So we've got 30, 60, 90, 120, and then 30 degrees more would be 150. Exactly in the middle of those would be 135. And then 30 would be 210, 30 more would be 240. Exactly in the middle of those would be 225. And then 30 more would be 300, 330. Exactly in the middle of those would be 315. And then 0 and 360 are considered to be the same. Okay. So now at this point, we just have to remember values that are in the first quadrant are positive, positive, positive for x, positive for y. So now when I look at quadrant 2, I'm going to have a negative x value and a positive y value. So this point over here went to the right 1/2 and up root 3 over 2. This one went to the left 1/2 and up root 3 over 2. This one went left root 2 over 2, up root 2 over 2. This other point went left root 3 over 2, up 1/2. Points in the third quadrant are negative, negative, because they go left and down. So this point right here went left root 3 over 2, down 1/2. And then we go left root 2 over 2, down root 2 over 2. And then we have left 1/2, down root 3 over 2. And in the fourth quadrant, our points are positive for x and negative for y. So this one would have gone over 1/2, but down root 3 over 2. And over root 2 over 2, but down root 2 over 2. And then over root 3 over 2, but down 1/2. Okay? And then next, we can do the radian measurements. So I know that 0 degrees is 0 pi, or you could just write 0. I know that 180 degrees is 1 pi. And I know if I go all the way around again, then 360 degrees is 2 pi. Now, you could do the radian measurements just by converting each of your degrees on your calculator. That would be one way of converting those and getting all the radian measurements. But it's actually just fractions, really. So if this is from 0 to 1 right here, then this would be 1/2. So we have 0, 1/2, 1. So 1/2 I'm going to write as pi halves. So I've got 1/2, 2 halves would be 1. 3 halves would go down here, so 3 pi halves, and then 4 halves is 2. And I can break up that fraction even more. So if I think of what's halfway between 0 and half, it'd be a fourth. So I've got 1/4 right here, pi fourths, 2/4 right here, 3/4 right here, 4/4 right here for 1, 5/4 right here, 6/4 right here, which is the same as 3 over 2 if you simplify the fraction, 7/4 over here, and then 8/4 to finalize it, which is the same as 2. And then if we break that up even more, you can see we've got these sections that are evenly distributed, like that, and there are 6 of them, so they would be by 6. So we've got 1/6 right here, 2/6 right here, which is the same as a third, 3/6 right here, which is the same as a half, 4/6 right here, which is 2/3, 5/6, 6/6, which is 1, 7/6, 8/6 would be 4 pi thirds, 9/6, which we already had, 10/6, which would be 5 pi thirds, 11/6, and then 12 would be the 2 pi. Okay, so those are all the values on the unit circle that we need. Now there's one more thing that I want to talk about. So, and we're going to draw just up here, let's draw this little sketch. So we're just drawing a triangle again, and I'm going to say this is our theta, whatever it happens to be. It could be 45 degrees, it could be 30 degrees, it could be whatever. Our radius is always a length of 1. The bottom part is always your x. This part is always your y. So now, if I wanted to know what sine of theta was, I would say opposite over hypotenuse. So sine of theta is y over 1. And y over 1 we know is just y. So if I ever want to know what sine of an angle is, I just have to look at the y coordinate at that point. Cos theta is adjacent over hypotenuse. So that's x over 1, which is just plain old x. And then tangent of theta is opposite over adjacent, so y over x, which based off what we just said is actually the same thing as sine over cosine. So those are 3 important things to remember. Alright, so we're going to go ahead and write them on the front of our page. So we have the x coordinate is cos, and the y coordinate is sine. And then we also have that tan is the same thing as sine over cos, or if you need to remember that as y over x, you could remember it that way. So those are good things to keep in mind as well as we work with the unit circle. And then let's actually go ahead and add one more thing up here. If you guys recall, sine theta is the same as 1 over, actually, let's write it differently. I'm going to say, sorry, I did not plan putting this on the video, if you could tell by my hesitation there, but I think it's good. So if I want to know what cosecant is, it's 1 over sine, which means that all I should do is take whatever ratio I have for sine and I should flip it. If I want to know what secant theta is, all I have to do is flip cosine. And if I want to know what cotangent is, all I have to do is flip tangent. Alright, so those are good to remember as well. Okay, I think that's it. We're done.